Topic of this video is analyzing the graph of a rational function. This is a continuation of the previous video. Alright, so we're still dealing with r of x equals x squared over the denominator x squared plus x minus 6. We have completed steps 1 through 5. We're now ready to do step 6. Step 6 says use the zeros of the numerator and denominator of r to divide the x-axis into intervals. Note that we're back to using the original r function provided at the beginning of the problem. Determine where the graph of r is above or below the x-axis by choosing a number in each interval and evaluating r there. Plot the points found. Okay, great. So let's go ahead and do that. So in this particular problem, since there were no factors in common top and bottom, the original r and the reduced r are the same thing. We simply have it shown in two different forms here, polynomial form and factored form. All right, so we're going to find our zeros of the numerator, and we're going to find our zeros of the denominator, and we are going to put them on a number line, and that will help us to decide what points we want for our graph. All right, so first the numerator. So the numerator is x times x, and we want that to be 0. So by the zero product property, we get x equals 0, x equals 0. So 0 is one of the zeros of our numerator. All right, then we have the denominator. Our denominator is in factored form x plus 3 times x minus 2. When we set that equal to 0, by the zero product property, we get x plus 3 equals 0, x minus 2 equals 0. Solving each one, we get x equals negative 3, x equals 2. So those values are going to go on our number line as well. Those are our zeros. All right, now that we know our zeros, we need to pick numbers that are in each one of these intervals. So we need something less than negative 3. We need something between negative 3 and 0. We need something between 0 and 2, and we need something bigger than 2. Well, less than negative 3, but still a convenient number, for me, the choice is negative 4. Between negative 3 and 0, but still a convenient number, the choice for me would be negative 1. Between 0 and 2, but still a convenient number, my choice would be positive 1. And bigger than 2, but still a convenient number, my choice would be 3. So we're going to have the following x coordinates of our points: negative 4, negative 1, positive 1, and 3. Now we just need to find what are the y values that go with those x values. And we can find that by plugging in to our function. All right, so let's start with the first value. So if x is equal to negative 4, we can plug into our polynomial form or our factored form. Either way is fine. In this case, I'm going to choose the factored form. So we have negative 4 times negative 4 over negative 4 plus 3 times negative 4 minus 2. So negative 4 times negative 4 is positive 16. Negative 4 plus 3 is negative 1. Minus 4 minus 2 more is minus 6. So I get 16/6, which is 8/3, which as a decimal is 2.6 repeating. So 2.6 repeating. All right, next value of x. If x equals negative 1, then plugging in, we would have negative 1 times negative 1 over negative 1 plus 3, negative 1 minus 2. Negative 1 times negative 1 is positive 1. Negative 1 plus 3 is positive 2. Negative 1 minus 2 more is negative 3. So this is negative 1/6. And the decimal version of negative 1/6 is negative 0.16 bar. I'll put that here. So negative 1 gives me the result negative 0.16 bar. Okay, next, if x equals positive 1. So then I'm going to have a positive 1 times a positive 1 over 1 plus 3, 1 minus 2. 1 times 1 is 1. 1 plus 3 is 4. 1 minus 2 is negative 1. So this is negative 1/4, which is equal to the decimal negative 0.25. No bar here. This is a terminating decimal. All right, so 1 is the x coordinate, and the y coordinate is negative 0.25. All right, and that just leaves us one more point, which is an x value of 3. I've run out of room, so I'm going to make some space up here. All right, here we go. If x equals 3, then we would have 3 times 3 over, in parentheses 3 plus 3, and in parentheses 3 minus 2. 3 times 3 is 9. 3 plus 3 is 6. 3 minus 2 is 1. So we get 9/6, which reduces to 3/2, which is the decimal 1.5. 1.5. Okay, we've now completed all 6 steps. The only thing left to do now is to use all of the information that we gathered to create the graph of our rational function, and we'll do that in our next video.